Before we start, if you want to understand the technology that's shaping our future, explained in a way that's incredibly simple, go ahead and hit that like and subscribe button. I specialize in breaking down complex tech into easy-to-digest ideas. Now, let's dive in. Imagine a world not in the distant future, but right now, where your devices seem to read your mind. Picture this. You pick up your phone, and it already knows what you want, anticipating your needs before you even type a single letter into the search bar. This isn't science fiction. You open YouTube, and it presents you with the perfect video suggestions, almost as if it knows your current mood. You unlock your phone with just a glance. It recognizes your face instantly and securely. You browse an online store, and it showcases exactly the products you were looking for, sometimes things you didn't even know you needed. This seamless, predictive experience isn't magic. It's a powerful technology called machine learning, and it's the invisible engine running our digital world. So, what exactly is machine learning? At its core, machine learning is a fascinating subfield of artificial intelligence. The key idea is this. Instead of giving a computer a rigid set of instructions for every single task, we design systems that can learn from data. It's about creating algorithms that allow machines to identify patterns, make decisions, and improve their performance over time, all without being explicitly programmed for each specific outcome. To truly grasp this, let's compare it to the old way of doing things. In traditional programming, a developer has to manually write out every single rule. For example, to identify a spam email, you'd write code like, if the email contains free money, then mark as spam. But what if the spammers change their tactics? You'd have to write more rules, endlessly. In machine learning, the approach is fundamentally different. The machine analyzes thousands of examples of spam and non-spam emails and creates its own rules by identifying the underlying patterns. It learns what's spam-like, rather than being told. Think of machine learning like teaching a child. You don't give a toddler a textbook on feline anatomy to teach them what a cat is. Instead, you show them pictures. You point out cats in the real world. Look, a cat. That's a fluffy cat. There's another cat. After seeing many examples, the child's brain builds a model of what a cat is. Eventually, they can see a cat they've never encountered before and confidently say, cat! Machine learning works on the exact same principle. The more data or examples it sees, the more accurate and smarter it gets. It's the digital equivalent of learning from experience. So how does this learning process actually work? We can break it down into 4 fundamental steps. Step 1. Data collection. You need a lot of relevant data. Step 2. Training the model. This is where the magic happens. You feed the data into your algorithm, allowing it to learn the patterns. Step 3. Testing the model. You use a separate set of data that the model hasn't seen before to check its accuracy. And finally, step 4. Making predictions. Once the model is trained and tested, you can use it to make predictions on new, real-world data. For example, to predict house prices, you would first collect data on thousands of houses. Their size, number of bedrooms, location, and their final sale price. You'd use this to train a model. The model learns the complex relationships between these features and the price. Then, you can give it the details of a new house, and it will predict a likely sale price. Now, machine learning isn't a one-size-fits-all tool. There are different types, each suited for different tasks. The first and most common type is supervised learning. The key word here is supervised, which means we are teaching the model with labeled data. We provide the algorithm with inputs and the correct outputs. It's like having an answer key while you study. A classic example is email spam detection. The model is trained on a massive data set of emails that have already been labeled by humans as either spam or not spam. The model's job is to learn the function that maps the input, the email content, to the output, the label, so it can then make accurate predictions on new incoming emails. Second, we have unsupervised learning. As the name suggests, this is the opposite. Here, the data has no labels. There is no answer key. The goal is for the model to explore the data on its own and find hidden structures or patterns within it, Imagine giving a machine a huge database of customer purchasing data without any other information. An unsupervised learning algorithm could automatically group customers into different segments. For example, frequent bargain hunters, high-spending weekend shoppers, or new users, based purely on their buying behavior. Businesses can then use these discovered segments to create targeted marketing campaigns. The third major type is reinforcement learning. This is a fascinating area that's all about learning through trial and error. The model, often called an agent, learns to make decisions by performing actions in an environment to achieve a goal. When it takes an action that gets it closer to the goal, it receives a reward. When it makes a mistake, it receives a punishment or a negative reward. Over millions of trials, it learns the optimal strategy to maximize its total reward. This is the technology behind AIs that can master complex games like chess and Go, but it's also crucial for training robots to perform tasks and for developing the decision-making systems in self-driving cars. Once you know what to look for, you'll realize that machine learning is truly everywhere. It's the engine that powers the recommendation systems on Netflix, YouTube, and Spotify, curating content just for you. It's the intelligence inside voice assistants like Siri and Alexa, allowing them to understand and respond to your commands. It's how Google Maps predicts traffic and finds you the fastest route. It's used in facial recognition to unlock your devices and tag friends in photos. It's even revolutionizing healthcare, with AIs that can help doctors diagnose diseases from medical images with incredible accuracy. And of course, it's the brain behind the rapid development of self-driving cars. Machine learning is quietly and efficiently running the digital world behind the scenes. So, why has machine learning become so powerful and pervasive? There are three key advantages: automation, speed, and accuracy. First, automation. ML can automate complex and repetitive tasks that would be impossible or incredibly tedious for humans. Second, speed and scale. It can process and analyze massive data sets far beyond human capability, uncovering insights in minutes that might take people years to find. And third, it continuously improves. A well-designed ML model can learn from new data and adapt over time, becoming more accurate and efficient. For businesses, this translates directly into saving time, reducing costs, and making smarter, data-driven decisions that drive growth and efficiency. But it's not all seamless perfection. Machine learning also comes with significant challenges. First, it's data hungry. To be effective, most models require massive amounts of high-quality data, which can be difficult and expensive to acquire. Second, it requires immense computational power. Training large, complex models demands powerful hardware, often specialized GPUs, which can be a major barrier. And perhaps the most critical challenge is the problem of bias. An AI model is only as good as the data it's trained on. If the training data contains historical biases, whether they're related to race, gender, or anything else, the model will learn and even amplify those biases in its predictions. This can lead to unfair and discriminatory outcomes, and it's a major ethical concern that developers are actively working to solve. Looking ahead, the future of machine learning is boundless. It will be the driving force behind smarter cities, more effective and personalized healthcare, and increasingly sophisticated robotics. It will continue to make our technology more intuitive, helpful, and integrated into our lives. Because of this, learning ML today can open doors to some of the most exciting and high-paying careers in the entire tech industry. It is, without a doubt, one of the most in-demand skills of our time. So now you know the fundamentals of how machines learn. If this video helped demystify the topic for you, show your support with a like and subscribe for more simple tech explainers. And the next time your phone finishes your sentence or suggests the perfect song, you'll know exactly why.